before we proceed further, I would like to mention about the big picture just in case you get a little bit lost. So if you go back to, we talk about two examples so far. One is about reference copy, and the other one is about a shallow copy. Okay, let me just mention something here. I think the main thing really is to understand what this particular predicate is really meant to assert. About this particular cross notation here, I'll just box it over here. So think about this particular box. Okay, that expression there is really asking whether the pre-states is the same as, equivalent to, I'm just saying if they're the same state, right? If the all the values are the same. If the pre-state is the same as the post-states. This is really what the cross notation is really asserting, right? Yes or no, right? In the case where we are trying to make a change, in this case, we are simply trying to reassign the second slot of the array imp into gym. Since there is a change, so pre-state the same as post-state should really give us false. That's the expected answer. So that is why in the case of the shallow copy, you actually see true and true and true for all the iteration, even including the second iteration, because we got aliasing. So now the pre-state value and the post-state value are still considered as the same because they are simply referring to just this very latest string that's being assigned. So for the case of the reference copy, it is not appropriate to actually see the difference between the pre-state and post-states. And on the other hand, in the case we are using the same predicates over here to see if the pre-state and post-state are really the same, but now we're doing a shallow copy instead. So what that can assert is, so now when you reach the second iteration, it's actually now false rather than true, because the second slot of the post-state is now referring to this latest assigned string, but now the pre-state, being a shallow copy, is now the second slot is referring to this string mark. So now if you compare these two, they are not the same. So now the this particular predicate over here is now going to give us false as the answer. Okay, so this answer over here. So now, is the pre-states the same as the post-states? So now the answer would just be false, and this is actually accurate because we did make a change in the post-states. That's what we have gone through so far from the previous video. So I think having a very quick summary will be useful before we proceed. We have to see, I call this first level change because you can think about this is like the first level for your data structure. First level will be element 1, element 2, element 3. We simply try to reassign the first level members in the array. So that's why I call that first level change. So now we want to ask the following. What if the change we make is beyond a reassignment at the first level member of the array? If we are trying to make some change beyond the first level reassignments of the member of the array, is shallow copy sufficient to actually make us see the change? That's the question. Okay, that's something we're going to find out in the next scenario. Let's take a look at the slides and then we'll follow the same pattern of reasoning. So now this is what we have seen for the shallow copy. So now we want to see another case of the shallow copy. So now you can see line number 1, we're still making a shallow copy. Okay, I'm going to illustrate that in just a moment. But now what we want to do now is to say, of course, we can still compare to see if the pre-state and post-states, are they the same objects? Of course not, because by definition for the shallow copy, it should be false, right? And then, so now the change we want to do is rather than just reassigning the reference at the first level, meaning that rather than reassigning just slot number 2 of the array, we want to change the contents of slot number 2. Change the contents of the string that's pointed by slot number 2 more precisely. But now we want to see what's going to happen if we only make a shallow copy. Are we able to see the change between the pre-states, imp, and the post-states, which is imp? Let's see. So now we're still making a shallow copy, but let's set up the things together. So we know that this is going to be false. Okay, that's no question. So now let's draw that. For this particular shallow copy, okay, let's just draw it very quickly. Let me just make it a little bit thinner. So we have old imp is a shallow copy. So now it's pointing to an array of size 3. And each element is simply just going to be a reference copy by definition of shallow copy, right? Oh, let me draw a little bit better. Okay, so now this is pointing to this string over here, and this is pointing to the third string. Okay, that's a shallow copy. And again, this is the pre-states. And after making this particular change over here, let's see what should be the change. How should we visualize this change? We go to slot number 2 of the array, which is a string. And then we try to append to that string itself, rather than just reassigning that entire string to something else. That's what we did previously. But now we're doing something different. So now go to slot number 2 of imp. Slot number 2 here is actually pointing to this particular string. So rather than reassigning that, we're just going to change the string. To be more precise, we're going to append to the string star star star. So you can think about, we'll simply say this string over here, right? It's now just going to become mark star star star. We are not even making a new string, just append to the end of the string. So it's now mark star star star. So I call this a second level change because we are modifying whatever that's being pointed to at the first level, which are the members of the array. So now let's take a look what's going to happen. Again, we have to understand very well that this particular across notation over here is asking the following question. Is the pre-states the same as the post-states? That's what we are asking, whether that's true or false. Okay, it should be false. That's what we expect to see because we did modify something. We did append to the elements of the array. I mean the string. So now this imp over here is now the post states. So now we are comparing the pre-states versus the post states using this particular across notation for predicates. Again, we have 3 iterations. Let's take a look again. Let's be very thorough over here. So we got iteration number 2, iteration 1 through 3, first iteration, second iteration, and also third iteration. For the first one, the first and third should be very similar. Imp at position 1, the same as old imp at position 1. So that's the first iteration, and second one will be imp at position 2, the same as old imp at position 2, and also the third one will be imp at position 3, the same as old imp at position 3. So we got 3 iterations. Let's see the first iteration here. So now for the first iteration, should it be true or false? Let's see. Imp 1 is referring to this particular string. Old imp 1 is referring to this particular string. So they're referring to the same. So iteration number 1 should be true. And then similarly, you can also argue that for iteration number 3, it will also be true. I'll leave that to you. That's very easy to see from the diagram. What about iteration number 2? Because iteration number 2 is indeed the change that we made over here, right? We really made a change on slot number 2. Well, actually, whatever string object that's pointed by slot number 2. Is this going to be true or false? What we really expect to see will be false. That's what we expect to see. But it's not going to be the case. Why? Let's now annotate it. So now, what happens to imp number 2? Imp number 2 is actually pointing to this particular string over here. Okay, and what about old imp number 2? That's a pre-states. Old imp number 2 is also pointing to, by definition, the same string. So now if you're really comparing this orange and the pink, they're the same string. So now are they the same string? Yes. So that means we also get true over here. So we get true, true, and true. So eventually we also got true as the answer. So the true tells us it is inappropriate. to see the change. So let's do a very quick summary. If you're trying to make only a first level change, in that case, if you only trying to make a first level change, reference copy is not the way to go to make a shallow. Sorry, let me say it again. If you're trying to make a first level change, then making a reference copy of the pre-states is not appropriate, because it's simply going to tell you it's simply just true that the pre-state and post-state are the same. If you're making a first level change still, but if you try to make a shallow copy of the pre-states, in that case, it will tell you it's actually false. And this will be appropriate because it's telling you there's a change between the pre-state and the post-states. On the other hand, if you go beyond the first level change, in that case, using a shallow copy still would not be sufficient for you to tell the difference between the pre and post state, because it will still give you true. That means the pre-state and post-state are considered as identical, but they should not be, because there was indeed a change that's beyond the first level. Okay, so these are the three things we have seen for the reference copy and shallow copy. So now the ultimate answer goes like this. If you ever try to make a change that's beyond the first level, which means second level, third level, fourth level, etc., having reference copy or shallow copy of the pre-states would not be sufficient. What you can do, your only option will be make a deep copy. Let's see how that will work. Let me go back to the slides, and we have seen everything already over here. And by the way, so let me reveal the answer over here. That should just be true over here, right? That's what we agree. Let me go back to the slides, and then this is something I just illustrated. You can again try to compare. So now let's do a deep copy. So what we would like to do is we're going to do a deep copy, and then we're going to see what's going to happen if we try to make a first level change by reassigning the member of the array, and we are trying to make a second level change by modifying just the string objects pointing to by the first level attributes of the array. So these are the two. And is deep copy suitable for both cases? I can tell you the answer first. Yes, it turns out deep copy will always be the safest bet if you want to compare the pre and post state. However, if you're only making the first level change, then having a deep copy may be a overkill for your performance, because if your object structure is arbitrary, is very large, in that case making a deep copy unnecessarily may slow down your performance. So that's why you have to make an educational judgment. If you're only making a first level change, in that case just do the shallow copy. If you're going beyond the first level, you want to do deep copy. It's a very quick pre-summary before we explain it. Okay, so now let's say we got deep twin over here, and then we try to compare. So this one should be easy, because by definition deep copy will create just a different object, so that should be false. And now let's say we do the first level change just to warm up quickly. Okay, so now how do we visualize this? Okay, let's see quickly here. Again, this should be false as we agree, and then the change we're going to let's now visualize the deep copy first. Okay, we're going to draw a deep copy, which means we're going to create independent object structure without any aliasing, no aliasing. So what's going to happen is, for the pre-states, it's going to be old imp. Over here, first of all, it's going to create a new array, just like the first step for shallow copy. And then for each slot, what's going to happen is, I'll just give you one position. What happened to old imp at position 1 is simply just going to be, rather than a reference copy, it's going to be imp at position 1 recursively dot deep twin. And let's say slot number 1 over here is referring to a string. A deep copy of the string will just be another string object. Okay, so now this is now pointing to just another string object here. Okay, I'll just save some space for drawing. I'll say here will just be Alan. You can see this is independent from this particular string, right? They are completely independent. And similarly, for slot number 2 is going to be a copy of Mark. And slot number 3 is going to be a copy of Tom. Okay, that's a deep copy here. So now what we want to do is we want to see how to answer this. Oh, let's do the change first to create the post states before we try to compare. If we do only the first level change, what's going to happen is, again, we know how to do this change. We simply go to slot number 2 and then redirect that into Jim. And now this particular predicates for the across asking us to judge whether the pre-states and the post-states are the same, right? Is it the case? What do we expect to see? We should expect to see false because we do make a change over here. But it should be quite easy to compare. Again, we got 3 iterations, right? Iteration number 1, iteration number 2, iteration number 3. So we got first iteration, we got second iteration, we got third iteration. You pretty much know what I'm going to write. But for completeness, I'm going to write it. Okay. So now it's going to be imp at position 1, right? J here. So first iteration of J will be 1. Old imp, position 1. And imp. And also 2. Old imp at position 2. And imp, position 3. Old imp, position 3. And let me just do a little bit copy because this is only about the first level change visualization. When we visualize how to do beyond the first level change, the diagram I start with will be similar. Let me just copy that just to save a little bit time later. Okay, so now this will be something will come in just a moment, but I just want to paste that here. That's also a deep copy. And then also for all the iteration, okay, let me just be careful. I just want to copy this text. Okay, that's something I'm gonna need later. Okay, let's go back to this case. So now we want to evaluate this particular for all expression across. We got 3 iterations. Let's see iteration by iteration. For iteration number 1, let's see. So imp at position 1 is now imp is here. Is referring to this particular string, and then old imp at position 1. Old imp is here at position 1 is referring to a separate string, but they contain the same contents of the string. So when we use tilde over here to compare, so they are the same. So which means from the pre-state to the post-states, as far as the contents equality is concerned, the first slot has no change, which is true because we only change the second slot. Okay, so now let's go back to let me just put a true over here, and you can also do the same exercise for a third iteration. It will also be true. So now we want to find out for the second iteration. So now for the second iteration, let me mark something permanent for you. Implementation at position 2. So now this is pointing to this particular string over here, Jim. What about O implementation 2? O imp 2 is actually pointing to Mark. So Jim versus Mark should be false. Okay, so now if you try to evaluate a universal quantification, it's going to be true, false, true. So eventually it's going to be false. Okay, for the question here. So now this is appropriate. Because now we are able to see that the pre-states, when we go from the pre-state and the post to the post-state, there is a change, which is to reassign the Jim value over here. Okay, so now finally, let's see if the deep copy will also be suitable for when we go beyond the first level. In the case of shallow copy, we said that it was inappropriate because we were not able to see any change that's beyond the first level, right? That's what we just talked about. But now let's see for the deep copy here. Okay, let me show you a little bit slides before I come back to this visualization, final one. And of course, let me just also reveal this particular value over here, so you will know it's actually false, right? So now let's go back to the slides. final case to look at, also for deep copy. So now we're still trying to make a deep copy here. And then, of course, by definition, it will be a different object to begin with. So that should be false. And then now we try to do what we did before to the shallow copy, but now we're doing that to the deep copy. That's beyond the first level of change. Are we going to get true or false for the universal quantification? Okay, let's switch to illustration here. Again, the critical question we are really asking here is this particular across notation. We are asking whether the pre-states is it the same as the post-states. Is it the case? What do we expect to see? It should be false because we are appending, we are changing something. Okay, so now with the initialization already set up, so old imp over here is the deep copy, right? That's what we drew previously. Now we're going to evaluate iteration by iteration. Iteration number 1 will be very obvious. Okay, implementation 1 referring to this. Old imp 1 is referring to this. Alan and Alan, they're the same string content-wise. So now we are fine. So now for iteration 1 is true. Similarly for iteration 3, that'll be true as well. So I'll leave that to you. So let's now talk about the second iteration to see if we will be able to see the change by having false for content comparison. Let's say implementation 2. Implementation at slot number 2 over here is now referring to this particular string over here. Okay, and then, oh, I forgot to impose the change, sorry. Okay, let's do one more thing. So I forgot to actually write this. So we say append star 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 to the end, right? So now this mark over here has become star star star. So I just forgot to do it. Sorry about that. And of course, the first iteration and third iteration will still be true. Okay, for this for similar reasons. So we don't have to worry. Nothing has gone wrong. So now when we talk about imp at position 2. Is now referring to this particular string which has been modified by this line being mark star star star. What about the pre-states? The pre-state over here, old imp over here as slot number 2 is now referring to mark. So now we're comparing mark versus mark star star star. Are they the string? They are not. So now we are really having a very exciting result by having the pre-state and the post-state being different. So we will be able to see the difference over here. Okay. So now this is the pre-states and this is the post-states, and they are considered as different. So now if you reveal this result over here, it would be false. Okay. So that's appropriate because now we will be able to see the difference. Okay, so now that will be the final scenario that we have to talk about. Okay, you just go on with this. Okay, let me just end this particular example by referring you to the code example. So you can download this particular source code. If you click on the link, it's available as a compilable iPhone project. I would suggest you, as you learn from the introductory tutorial videos, you can actually examine the objects in the debugger. I would suggest you actually try each of the scenario to actually see how to make a reference copy, how to make a shallow copy, and how to make a deep copy, and compare them. Okay, that's what I would suggest. To conclude this example here, I want to mention that the way we actually create the pre-states by having old imp being either a reference copy, shallow copy, or deep copy of the imp. Whenever we try to make a change to the imp, it becomes the post-states. So we want to make sure the pre-state somehow can be a reference point later for us to do some comparison to see whether the pre-state and the post-state are really the same or different. So this will really be the essence of writing a complete post condition that we will see later part of this lecture. So I would suggest before you move on, make sure you really understand about the 3 levels of copying and also how specifically it has been applied in these 3 scenarios that we talk about for the either first level change or second level change for either shallow copy, reference copy, or deep copy. Review this before you move on.